Assalamu alaikum dear students. Today we are starting the second chapter of AS Physics. It is kinematics, and there are a number of basic concepts, and you have to recall those concepts, as well as we have to develop some other aspects of this chapter, and inshallah we will complete this chapter, but you have to be regular with this chapter, and you have to follow all the you can say videos which I will upload, so you can understand this chapter properly. So we are starting today this chapter of kinematics. Basically, we have a branch of physics which is known as mechanics, which deals with the motion of the bodies. So mechanics is simply, you can say, the branch of physics which deals with the motion of the body. But basically, the mechanics we can have, or we can do two branches. We can have two branches of mechanics, and one branch is kinematics, the other branch is dynamics. As far as the kinematics is concerned, this is the study of motion without the concentration of causes of motion. Yani when we will consider, or when we will study the you can say kinematics, we will not consider the causes, or we will not consider the forces making any changes in the you can say displacements or velocities or acceleration, whatever, but the whole discussion will be without consideration of the causes. But when we will come to the dynamics, you have to consider the motion of bodies with the consideration of the causes of motion. Yani in that case, you will consider the forces and so on. But for the time being, we are starting from the kinematics. Now, when you will consider the motion, actually, the question, what is rest or what is motion? So most of the students have this answer: when the body is not moving, the body is at rest. When the body is moving, the body is in motion. But this is something like this, that if you are asking someone, where do you live, in front of Ali's house, where Ali's house is in front of my house, but still you do not know where both of them are living. So the point is that if you are defining one term in terms of another term, this is some sort of useless situation. So here we have to define rest and motion in a proper way, and basically these terms, rest and motions, have their own definitions. And first of all, we have to understand this point, that whether it's a rest or it's a motion, this is basically a state of a body. So what is the state of rest, or when you will say that the body is at rest? So this will be a proper definition: the state of a body when the body does not change its position with respect to its surrounding. The state of a body when the body does not change its position with respect to its surrounding. What does this mean? So simply you can say that if we have, suppose, a table, and on the table we have, say, a book or a ball is lying on the table. So of course, around this table we have certain we can say surrounding of this table, like here you have one wall, here you have another wall, and if the table is lying in a room, then we have different walls. And on one side, suppose we have here a picture, on one side we have a clock, and same is the case other side we have a television set, and somewhere here a person is standing. So if this ball is not changing its position with respect to all these surroundings and all these things around the ball, we will say that the ball is at rest. So this is very, very important, that the ball is in the state of rest when the ball is not changing its position with respect to its surrounding. Like suppose if we are sitting in a room, so maybe we are not changing my or our position in my room with respect to the surrounding, but if you will consider the outside of the room, so you can say that as my room is of course on the surface of the earth and the earth is orbiting, so I am not in rest according to some other planets. So how you will define motion? So simply you can say the state of a body when it changes its position with respect to its surrounding. Yani suppose you are moving on a road, you are moving on a road and your position is changing constantly, and here you are after few minutes you are changing your position from position 1 to 3 4. So you will say that as you are changing your position with respect to your surrounding, of course here maybe you have a shop, on this side you have a electric pole, somewhere here you have a tree, somewhere here you have a car standing on this side. So all these things are making this surrounding, and when you are changing your position with respect to all these objects, all these surroundings, so at that time you will say that you are in motion. So this is very, very important, that state of rest and a state of motion. State of rest when the body is not changing its position with its surrounding, and the state of motion when the body is constantly changing, whether constantly or not constantly, but it's changing its position with respect to its surrounding, then the body is said to be in motion. Now as I just have already given you this example, that even if the ball is at rest according to this surrounding, so as soon as you will change the surrounding, you will have a different situation. Yani, as I have already given you this example, that the room is at rest and all the surrounding objects are at rest, and the ball is at rest because the ball is not changing position according to these objects, but as the room itself is orbiting with the earth, so you can say that if the surrounding you have to consider not the room but the, you can say, surrounding of the earth, or the surrounding in you can say that respect that the earth is our surrounding, then you will say that the ball is moving. Yani if the suppose you have another example, if you have an elevator and in elevator there are two passengers, so they are not changing their position, so with respect to each other, yani the surrounding, if the surrounding is the elevator, then what is the situation? The situation is that both of these two persons will be at rest with respect to each other. But as you know that the elevator is moving, so when the elevator is moving, suppose in the upward direction, so both of these people are moving. So if a person is standing somewhere outside, so with respect to the third person, these two persons, like person 1 and person 2, they are now in motion, because the surrounding now is different for these you can say people where 1 and 2 are at rest with respect to each other, but 1 and 2 are moving with respect to person 3. Another very interesting thing is that 1 and 2 can say that we are not moving, the person 3 is moving, but the person 3 can say that I am not moving, but these two, in person 1 and person 2, are moving. So we have to consider that what is the surrounding. So this is very, very important term, and when you are going to study the mechanics thing, you must know the definition of rest and motion, because if you want to study physics, you have to understand these things. Ultimately, what we can make the statement for the rest and motion, first line, which is very important. There is no absolute motion or rest in this universe. So what we are saying, as I have just given you this example, that these two persons are at rest with respect to each other, but these two persons are moving with respect to the third person. So they cannot say that they are at rest or they are moving. So that's why we are using this sentence, that there is no absolute motion or rest in this universe. Then we can say that all the states of rest or motion or rest are relative to the frame of reference and its surrounding. What is the frame of reference? Basically, it's a surrounding. So remember this thing, these two things, these two statements are very, very important statements of physics. And when you are starting mechanics, you have to understand these 2 points. Now we are moving towards another very simple term which we have been using. Actually, quickly we have to go through these definitions, and we have to review and recall these definitions. As far as the distance is concerned, the definition is the total length covered by a body. And when a body is moving, so the total length covered by a body will be distance. So this is simple definition of distance, and we have been studying this definition before as well. We also know that the unit, SI unit of distance is nothing but is meter, and the symbol of meter is m. Here we can recall that if a person is moving from the point O, or the origin is O, and after some time, any time from T1, time T1 was 0 when the person was at A or origin, and from A to B the person has moved to 5 meter distance, and then from B to C again 5 meter, from C to D 4 meter, and then D to E 6 meter. So simply what you can say, the total distance covered, simply as we have already studied in the scalar and vector concept as well, that the total distance is the scalar quantity, and simply we can add all these distances to or lengths to get our distance. So 5, 5, 4 and 6. So this is the total distance covered, which is 20 meter. I think this is very simple, so I'm not emphasizing on this point or giving much time. Here, one thing which is very much related to the distance is speed. So how you will define speed? So simply the rate of change of distance is speed. So this is simple definition. Now the point is that what is the equation? So simply you can say change of distance divided by change of time. So what is the change of distance? x2 minus x1 divided by t2 minus t1 is the time. Change of distance is x2 minus x1, t2 minus t1 is the time interval. Now in this example, the example above, if you are considering this distance, suppose you are going from A to B, so the distance covered is 5 meter. So initial distance is the origin, you can say x1 is equal to 0. The time was 0, but now as the distance has covered, 5 meter distance has covered, so you can say that from A to B, x2 distance has been covered. So simply 5 minus 0 is x2 minus x1, and if during this the time taken is 5 seconds, yani from t1 is 0 to t2, which is 5 seconds, so simply you can say that the time interval is of 5 seconds, and therefore we can get the speed, which is nothing but 1 meter per second, or you can write in this way 1 meter per second. So this is how you are calculating your speed. Similarly, if you are going from B to C, so in this case you can say x3 minus x2, x3 is 10 and x2 is 5, and during this displacement the time t3 minus t2 you have taken, and if it is 10 and 5, and from this point B to point C you have covered another distance, but now the total time from your t1 to t3 is 10 seconds. So what you will do, here you have simply 10 minus 5, and again you are getting a magnitude which is 1 meter per second. Similarly, you can find the speed between the point C and D. So point C and D, you have x3 and x4. So here you can write x4 minus x3, and of course t4 minus t3, not this one. This will be t4 minus t3. So if the time taken this time is 14 second, so what you will write, 14 minus 10, and the distance covered was also 4, time taken is 4 second. So again you are getting 1 meter per second, but it is not necessarily the same values you will get always. It means that if you have these values, you can say that the speed is constant throughout. But of course the you may have a situation where speed is not constant, but simple equation which you have to consider is this one, the rate of change of distance, or simply you can write change of distance divided by change of time. So this is simple because as we have studied in our scalar quantities, we can simply add or subtract or divide or multiply. So distance is the scalar quantity. Here even you can write this point that distance is a scalar quantity. Just to recall that why we are doing all these things, simple addition or subtraction or whatever. So this is how we are doing for the distance. Now as far as the displacement is concerned, this is very important. As far as the definition is concerned, it's very simple definition. The shortest distance covered in a specific direction. So this is something which is your displacement. Again the unit is same, yani meter. Now if you are taking the previous example, so over here if you are going from point A to B, B to C, C to D, and then D to E, and the origin is O or A, so the shortest distance is nothing but AE. So this shortest distance AE is your displacement. So AE is the displacement, and not only the magnitude is important, but here the direction is also important. Yani simply when you will go for the displacement, so it is very important to mention that shortest distance covered in a specific direction. And here we have to consider the direction as well. So simply again unit is same, but you can say that a displacement is a vector quantity. Now as far as the displacement is concerned, I think we need to explain few more things about the displacement, and here we will try to compare the displacement and distance concept. Like if you are considering this line, number lines, then you can say that from O to A to B, B to C, C to D, and so on, each distance is of 5 meter. So what we can say is the distance OD is 20 meter, and if you are going from O to D, the distance suppose is 20 meter. What suppose actually you have taken 5, 5, 5, the distance is 20 meter. But when you are coming from D to A and you are covering a distance of 15 meter, so as far as the total distance is covered, this is simply you have to add these two values, any 20 and 15, and you will get 35 meter. No specific direction, only the magnitude, and this is nothing but 35 meter. Yani you have covered the distance of 20 meter, and then you have this distance which is 15 meter. So the total distance will be of 35 meter. But as far as the displacement is concerned, this is very important. Here you have to consider that, like suppose you have covered a distance of 20 meter, but you have DA which is 15 meters. So where you are ultimately, so you can say the shortest distance between 2 points. So what is the shortest distance? From O to A is the shortest distance. So ultimately simply you can say that you have to subtract these two values and you will get the result, and of course this result is again in a specific direction, yani you have moved, ultimately your displacement is from your point O to point A. So you have a specific direction and the value is of 5 meter, not this situation like 35 meter. Here you have displacement only of 5. So basically you have to check that from where you are starting, and displacement will be taken from the origin to the terminal point. So initially you are here and you are moving here and there, and ultimately you are coming to this point. So this will be the displacement, as we have taken in the previous example, that we are going in all these directions and displacements are distance are being covered, but ultimately your destination is from A to E. So you have this ultimate displacement which is in a specific direction, and of course the value will be the shortest distance between 2 points, yani A and E. So similarly here you have the shortest distance which is from O to A. Now if you are considering another situation, and suppose you are going from O to D, O to D, here you are, yani O to D, you have covered a distance of 20 meter, but from D you are coming in opposite direction and you have covered a distance somewhere up to point Q. So what will happen? Again the same thing, where you are, what is your displacement? So your displacement is not 30 minus 20, but you will say that the displacement is from the origin to the final point. So from the origin to the final point is nothing but your minus 10 meter. Remember this thing, that minus is only showing the change in direction. So be careful. Now your displacement is minus 10, yani you are on the other side of the origin. If this is your positive side, this is your negative side or negative, you can say region. So simply you can say that we have the concepts of coordinates and coordinates and positive and negative, and similarly we can say that we have positive and negative sides. So in positive region, in negative region, so the point is that you have moved from O to D in positive region, and you have moved from D to Q. But remember this thing, that when you are moving from D to Q, you have actually came back to the original point which was 0 or O, and then you have moved towards another you can say region which is, or to the point which is Q. So the Q was in the negative region. So what is your displacement this time? Negative 10. And okay, now after displacement we have to discuss velocity. And you know, as far as the definition is concerned, rate of change of displacement is simply velocity. Units, you already know, units you have meter per second. And as far as the equation for the velocity is concerned, this is simply change of displacement divided by change of time. So you can write in this way, x2 minus x1 divided by t2 minus t1. In this example, if you are considering here this you can say line, and we are considering this line diagram, and the displacement, initial displacement, which is your OA, which is 5 meter, and then you have another displacement which is OE if you are considering from the origin, then the total displacement between these 2 points will be nothing but, or change of displacement will be 20. If the initial time was 1 second, yani from O to A you were taking 1 second, and for the displacement of this 25 meter you are taking 5 seconds. So what is the difference of time? 4. So ultimately you can say that the velocity is 5 meter per second, and of course you can say that this is your positive velocity, or the positive in all senses. You are moving on the line and you are on the positive side of the origin. Now the point is that if you are moving from E to A, then what will be the situation? So simply you can say that the the original distance is your OE, yani 25, and your final displacement is EA. So what you can say that EA minus OE is 20 minus 25. Yani initially this was the displacement, and now when you are coming back, your displacement is from E to A, and this is 20. So ultimately you can say that -5 you have, and this -5 is of course meter per second. So basically remember one thing, that this negative here is not showing the decrease in velocity. This -5 is only showing that you have changed the direction. So this is very important. Yani when you are going towards positive, the or change in towards positive, the velocity will be positive. But if the change is in negative, then of course, or your face you can say is towards the negative region, as you can see here, that your face is towards the negative region. Even if you are moving in the positive region, your velocity will be negative, and this negative, as I just told you, will not be the negative in sense of decrease, but this will be in sense of the direction. So this is very very important. Yani you have changed the direction, and this -5 is basically showing you that situation. On the other hand, if you are considering this suppose example, and here I am taking few values, and values are for 0 and x, sorry, t and x, 0 second, 1 second, 2, 3, 4, 5, 6 seconds. And during this, what is happening, the initial distance covered is 20 meter, then 18 meter, 15 meter, 20 meter, and so on. So what you will say, that if you are moving from point A to B, simply the displacement, the suppose final displacement is 18, and your initial displacement is 20 within a given time. So simply you can say that the negative here is showing you decrease in velocity. So this is very important. The time is of course for each and every interval you have considered, like suppose 1 second, but the point is that there is a of course value which is decreasing. So when the value of displacement is decreasing with time, you can say that velocity will be negative, and this time the negative velocity means a decrease in velocity. So be careful of this difference, that you may have a situation where the negative is only showing you the you can say change in direction, and sometimes you will see that this is showing you the change in direction. So this is very important, that here you have the change in direction and you have the change in displacement. Even as I said that you can consider here another example for velocity, like suppose initial displacement was your value, like here you have this value OB. So what is the displacement? So this is your initial displacement, which is 10. Now if you are coming from B to A, then this displacement is only 5. So the time, suppose you are taking for this is 1 second, so -5 meter per second is not showing you the decrease in velocity, but this is showing you only the change in direction. Yani first you are moving from O to B, and now you are coming from B to A. So this is showing you the change in velocity, and this is the value of -5. So be careful of this situation, and when inshallah we will go to the you can say graphs, we will see that what is happening as far as the graph is concerned. And inshallah in the coming classes we will discuss not only the you can say graphs in detail, but their required equations as well. So till then, Allah Hafiz. If you are new on this channel, subscribe this channel. If you have any comments, kindly give me your comments as well, so I can improve this. And if you have any problem, you can ask your problems as well. and share this channel so other students can also get benefit of it. Press the bell icon so whatever the new videos we will upload, you can get immediately, and in this way you can complete your course very easily. Any confusion you have, please ask and give me in your comments. So see you inshallah in the coming lectures. Allah Hafiz. Take care.